So this unit is really similar to what we already did, which is good for you guys because you already have a basis, but we're going to focus more on interpreting like dot plots, histograms, and box and whisker. So we're going to kind of look more of how they use it like in a job or, you know, like cities. We look at some city stuff they do and they compare, okay? So more focused on interpreting it and knowing what to do with that information than only making it, okay? All right, so these are your key terms. These should be like throughout your lesson. So when you get to the homework, you can go back in the pages and like find the definition and stuff, okay? Okay, this is where I want you to be starting at. So do we flip to that page that has the table? It says it's a really long table. It's like site number, amount of lead. Okay, just take like, I don't know, 30 seconds, a minute. Read this. You can read it up here on your paper, whichever you prefer. Read through that and see what they're looking at there, okay? Okay, so this table they give us, what are they looking at here? Like what's going on? Jackie?
The water contamination.
Water contamination, okay. Where are they looking at?
Greenville?
Yes, in different places throughout the city, right? In the little paragraph you read, there was some important information about what the number could be. What did it tell us?
15 parts, less than 15 parts per million.
Yes. So that's what it needed to be at or under, okay? Or no, under, just less than. All right, so we're going to look now kind of at, or what can we draw from that? So number 1 says, analyze the data collected using only the table. What conclusions can you draw about the amount of lead in the water at different sites? So I want you, this pilot is kind of, or this new stuff we're doing is really focused on conversation and talking through your ideas because, well, really you want to think, if this were like a city project, you're going to be talking to people who work there. You're not going to make all the decisions on your own, okay? It's going to be sort of a team effort, okay? So take like a minute, I'll put a timer on, and talk with your group about what you guys know from this table. There's not really wrong answers because there's a few things you could know, okay? So take a minute, talk about what you know, write something down. Okay, time up. So like, you know, Ms. Robinson said, you don't want lead in your water, right? So like when I took my daughter London to the doctor a while back, they do like a test and make sure they don't have lead, okay? Kind of make sure that that's all okay. So tell me something you guys could conclude or something you know from the table. Who has something? Priscilla, what did you say?
22 is the highest.
Okay, so 22 is the highest. At site what?
2.
Yes, at site 2. Oops. All right, did anyone say something different? So what's something else? So site 2 is in trouble, right? That's an issue. What about the other sites?
The other sites have lower.
Okay, so are they okay?
Yeah.
Yeah, so all the other sites are pretty much in the clear. It doesn't have to be exactly like mine, okay? I'm just saying something that there is a few things you could have picked from here. You could have said like, what was the lowest one maybe? 17. They only had 1, okay? So you can look at a few different things. All right. I'm actually going to skip 2 because I don't think there's room to make that there. But all right, so look at 3 then. You guys have 3? Oh, wait, no. So they made the dot plot for you here, okay? So this shows you what it would have been. That should look, it's all the data from the table, right? So a dot plot's going to be good when you have like a small amount of numbers. I think they're making these represent something probably. And it kind of shows you, it's quick to easily see what the most common number was, okay? Because of those dots stacked right up. It's really visual, okay? All right, so skip to mine doesn't look exactly like yours, but similar. So if you skip to number 1 on the next page. All right, I want you to read, or would anyone volunteer to read this? Drake, you want to read it? Okay, thank you.
According to the Environmental Protection Agency, if more than 10% of tap water samples are greater than or equal to 15 parts per billion, or ppb, then action is required to reduce levels.
Good. Okay, so that's kind of their guidelines of like, okay, when it's over this amount, we're going to have to do something because people are going to be in serious harm and unsafe, okay? So do we know, looking at the table, do we know what percent currently have that? Like just looking, do they give us a percent? No, so we need to find that percent, okay? So do you guys remember doing your proportion, hopefully? Like this. So if we're finding a percent, what goes over here? 100, and then the top is our x. Now we need to look at our table. So how many sites had greater than or equal to 15? Look at your table. How many sites? 1. Out of how many? That's your total. What?
20.
20. Okay. Do we remember how to make this into a percent?
Yes.
Cross.
Okay.
You cross multiply.
So I multiply 1 and 100, right?
1,000.
100. And then what do we do with it?
Divided by 20.
Divide it by 20.
5.
5. Good. All right, so 5%. So reread the question real quick and think of your answer. Is it a yes or a no then? Don't say it out, just read it. All right, so turn to your neighbor and tell them if you think yes or no.
Done.
I heard Jackie. I should hear a lot more voices. All right, Sam, what do you think? No? Nathan, how come? Why is it no? Okay, what was the percent they needed to take action for? 10. Were we at 10? No, so that's why. You would just say like it was less than the unsafe percentage or the unsafe amount. Okay. So now we have the mayor of Greenville wants to analyze the lead levels for the water in the entire city. The frequency table displays the data for the amount of lead in drinking water samples taken from all over. So what did he do differently in this data collection? What's different from the first part?
He made it into a frequency table.
Okay. What's different about where he took samples at?
It's all over Greenville.
All over. Before it was just like the 20 sites, so those were probably fairly small. Like, so this means maybe they took them down by Main Street and then by Boone or whatever, okay? And then now he's expanding it to the whole city, okay? Okay, we start with the frequency table when you're going to make a histogram. Okay, so remember that kind of looks like the bar graphs, no spaces. It has the kind of a number here that's split into like 0 to 5, etc. They set these up a little bit differently than we did, I will say. Each of these little sections, like 0 to 5, 5 to 10, is called a bin. Okay, so if you see that on your homework, it's a bin. Like that's a bin that you're putting all of those that fell into that category in. Okay? These are really good for displaying a lot of data. okay? So you can see quickly what those numbers are and where they fall at. Have that. This is what we're using. We're using this frequency table they made. Okay, and you see it number 2 on the bottom, you have all that space. Okay, if I'm going, okay, so we are going to make a histogram. So you guys up and down, and go like this and this. What should be the, like, I guess we would consider like the y-axis label, the up and down? What label is that going to be? This one?
No. Well, wait, you said.
Look, like from your table, sorry. From your table, what are we going to measure on the up and down side? No. The frequency. And what is the frequency measuring, though?
The amount of water?
Amount of what?
Water? Amount of lead in water?
Yes. Okay, so we'd say amount of lead. Leave a little space because we got to do our numbers. So look at the frequency. What numbers do we have? It starts at, what's our minimum frequency?
32.
Okay. What's the highest? 100. But what are we going to have to go by to cover? Because we still need to include 0, right? Because 0 to 32 is an amount. What?
The lowest number on there is 23.
Oh, 23. Okay, so what would be a good one to go by to get from 0 to 100? What? What did you say? 10. Yes, I would agree with that. So remember 0. Don't ever start 0 up here. I saw that a couple times. 0 is here. And then we just got 10. So count those up. They don't have to be perfect. Drake. Okay, so that's measuring the lead. And now the bins go along the bottom. So look at your table. What is the first bin? 0 to 5. And this is how they set them up a little bit differently than we did last unit, so I'll show you here.
Yeah,
So,
we always put the next number.
right, they just put 5 here. Then this would be 10, 15, 20. Is 25 the max one?
Yeah.
Okay. So they do it more like a number scale rather than ours is more of a label. Okay, and that's all right. So first bin, 0 to 5. I make it like a bar graph kind of so I know what that vertical bar. What should it go up to? 0 to 5. What's its frequency? 32. So you want to just kind of look a little over 30, right? Like I said, it's not going to be perfect. You can fill it in if you want. Mine's okay. Nathan, what's the second bin frequency? 5 to 10.
48.
55.
48?
Yeah.
Okay. So that's going to be where at? Where would I put 48?
Right under 50.
Yeah. And then if you see the bar goes all the way, takes up that whole 5 to 10 space. Okay? All right. Joan, what's the 10 to 15? 100. Okay, so that one's going to go all the way up. Okay, Drake, what's the 15 to 20 bin?
Where am I at? 15 to 20. 47.
Okay, so the other was 48, so try to make it like a little below that one to the left.
Oh, I'm here for today.
See?
Okay, and 20 to 25. Jalen, what's the frequency on that one? How many were in that one, that bin? 23, is that what you said? Okay, so a little above 20, right? Okay. Oop. So then we can kind of visually see what we have going on there, right? So what's the next question? What conclusions can you draw from the histogram? All right. So on number 3, I want you to write one statement down. I'll give you 1 minute. Write one thing down that you can conclude from the histogram. So the one we just drew, is that on a different page for you guys, the
Yes.
question? Okay, I'll
The
zoom
back
in.
of the page.
I'll zoom in on this one then so you can see. Okay, so one pretty much looks the same as ours, a little neater though. So what's a conclusion? 1 minute, go. What's one thing we can know from this, looking at this? Just tell me something you can observe from that. Jake, what's something we know from this? Okay. Like, this is your amount of lead, so which category, like, is the most common amount of lead? 10 to 15, right. Okay, so that you could say, like, most of the sites were in the 10 to 15 range. Is that an okay range to be in?
No.
What did it say, 15 or
Oh, yes.
yes, or less? So that means the 15's okay or less than that. About how many are in the bad range?
2.
No, it's not 2 though, look to the left.
Oh, my bad.
15 to 25.
This one has about how many sites?
About 50.
This one's about 50, and this one's about
25.
you have 20, 25. So, say approximate. So about how many sites have an issue?
70.
Right, so 70,
Yes.
yeah, ish, are bad, ish. 10 to 15 is most common, right? So there's a lot of things that you could say. 30 and 50, about 80 are well below, right? So there's a lot of things you could look at and see that wouldn't be wrong. One thing you may look at, if this were a city study, if they're looking at these ones that did really good, why is it useful to know which sites had such a low? Why would that be helpful? What could you do with that information? If you saw that, like, okay, Austin's house had a ton of lead in their water, but Priscilla's didn't have hardly any. What would you do then? What would you look at?
The
What?
pipes.
The pipes, maybe, okay, maybe what else may affect that?
How old things are.
Okay. Maybe, what about ground? Does water come from the ground?
Ow.
Maybe look at that. So you can look at things and see, basically, they're doing good, so how can we make these sites do good? What's happening there that is on this one, we knew these two were bad, because 15 was a cutoff.
Yeah, we don't have that picture.
Does that make sense? No, you did this, though. Your histograms should match. Transferable, okay? All right, I want to tell you on this one. So Marcel created a histogram to display the same data, all right? But I'll tell you, Marcel did not do a good job with this histogram. But I want you to think about why. So, Nick, you here? Think about our cutoff. What's the cutoff for the lead? What's the, no, like what should it be? Sorry.
Oh, 15.
15. So can we see where they're doing okay or where they're doing bad?
Well,
Halfway.
kind of.
If this
If
is
you
the
cut-
number, this is the number of sites. So this 10 to 20 range.
If you cut that in half,
Yeah.
Okay, but that just cuts the sites in half. Do we know, like, the first 15 sites, do we know their exact range or their exact lead amount? No. So we really don't know in here if these sites were at 10 or at 20 or at 14 or 16. So we needed that cutoff to be like 10 to 15. That way we know, like, ooh, these sites were good, these sites were bad. See how this one doesn't have the cutoff at 15 here? Does that make sense? So you want to make sure it's a number that's helpful for you. Okay. So now the city, so they're looking at your whole, their whole inspection now, right? Let me see what one we're on. Hold on. Skip to page M412 at the bottom. So box and whisker plots, okay? Again, we already did these. They use the called 5-number summary. It's basically what you get from your calculator, like minimum, maximum, Q1, Q3, interquartile, etc., okay? This is your example, okay? I'll keep it up here. So the first line represents the minimum. I usually just go in like this. Here, just watch up here real quick because you're going to make one, but I usually just see you have your number line, okay? This would be 0. So here's 0. I just put the lines first. A line for the minimum, a line for Q1, median, Q3, maximum, and then the 3 middle lines you connect for a box, and then the whiskers on the outside, okay? I know you already did those, so hopefully that's a refresher. But so you guys are going to make, so a box and whisker is useful when you're comparing 2 sets of data, because then you can see like directly which ones has a higher median or higher maximum, etc. For time's sake, I'm just going to have you do 1 and then your neighbor do 1, okay? So let's do whoever has taller socks does Greenville. Yeah. And the other person does Oaktown. Okay? So just a reminder here, whichever one you did, so like Greenville, the minimum was 1. I think that was technically 0, but either way you did it. So I just put a line above it. It's not directly on it. And then I would go to 8. So 2, 3, 4, 5, 6, 7, 8. That's the whisker. Then my next one is what? It's my next, or my median. 12, so 9, 10, 11, 12. Line here. 16, 13, 14, 15, 16. The 3 lines in the middle are your box for your interquartile range. And then 22. So 17, 18, 19, 20, 21.
It ends at
22. Okay? Now, on a box and whisker, each section, so look up here real quick. Each of these is 25% of the data. Okay? So the smaller the section, that means the more like sites or whatever that were in that range. Okay? Because if it's spread out more, there's less there. All right. So it says, suppose you work in the governor's office. So you're comparing the 2 cities. Write an analysis to present to the governor. So what is something you guys could say comparing Oaktown and Greenville? Oaktown's what? Better. How come? Why are they better?
Sounds cooler too.
Yeah.
Bigger numbers.
They have what numbers? Bigger? Do we want bigger numbers?
No, you want smaller.
Right? So Greenville actually has the bigger numbers, right? So we could say, so we may want to look then at Oaktown and see what they're doing differently to help fix Greenville. All right? Okay, last thing here. So this is page,
413.
yes, thank you. I don't have the page on mine, so I have to like open mine and see. All right, and these are on your homework, right? This part, so I want to make sure you're kind of get some examples.
Is there homework in this packet, or you give it to us individually?
Kind of both. I'll have to explain. Okay, so Nick collects data about the 100 tallest buildings in the United States. Drake? He wants to quickly determine between which 2 heights the top 25% of the data fall. So you're trying to say if a dot plot, histogram, or box and whisker would be best to show this. So if we want the top, he wants to know where the top 25 is. Which would be best to quickly pick the top 25%? Which one breaks it into 4 quarters? Yes. So I want box and whisker for that. Okay, 2. Lily conducted a school survey to determine how many problems each math teacher assigned for homework on Friday. So take 10 seconds with your group. See what you think. Dot plot, box and whisker, histogram. And think there aren't probably very many math teachers, right? So you're thinking smallish numbers. Okay, what did we say?
I said histograms, but they're like really easy to read.
Okay. I will say histograms are usually measuring big numbers.
So,
How many math teachers do you think there are, maybe?
4.
Okay. We have more than that, but a lot of schools don't because we're like the biggest size school. Okay. So which one deals best with small numbers? Dot plot, yes. Because it's like we just quickly like dot, 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 dot. All right, 3. The migration ranges of the white deer and mule deer populations in Montana are recorded and compared. Okay, we did this kind of, but I split it into 2 people. Which one is the best to show 2 different things? Like 2 different areas, 2 different breeds. What one?
Histogram?
No. Like, which one did we compare 2 different cities with? Box and whisker. See how, remember how the one was like right above the other? Like that. Okay, so if you have 2 different types like that.
I like the fact they said boxes and then you put them with me.
I was trying to address the histogram question. Okay, 4. A school district wanted to determine how many students in the entire district scored above a 70 on a standardized test. So which one's going to be easiest to see if they got a 70 or higher?
In
Which one has bins, though? Histogram. Good. We've been wanting to use that one the whole time, huh?
Insane.
I know, that's what I thought. I almost said, Jackie, this is your chance. Okay, so for the homework, so listen carefully. I want you to be confused. If you flip 2 pages there to M415, okay, that is the homework, but you have to complete it online because I'm trying to get you prepared for how the test will be for these. It will be through this program. So if you follow along here, so you'll go to Canvas, click the homework assignment, so it's homework, I'm sorry, skip these ones. Homework M4 T1, lesson 1. All right, so on Canvas, click that. And you'll click homework. There's a homework link. When you click that, it should take you to what's called Edulastic, and it's going to ask you to sign in. So click sign in with Google. All right, and you will have to, so this paper doesn't have the room for you to do the homework on that. You have to submit through this. Whatever you do, I can see. So like if you finish 2 problems, I can see that. If you finish all of them, I can see that. Okay? All right. So the first bit should just be vocab. It's like drag and drop. You can flip back in your notes if you need to find the vocab though. And then the bottom part is creating like a dot plot and a histogram.
Okay.
Okay?